Welcome to Neuron Short 4 about the convert range. Remember how in the second Neuron Short I explained that when it comes to programming the processing cards, there's always a trade-off between processing capabilities, density and redundancy? Well, the convert cards favor more video and audio processing functions over the amount of processing paths. Where with the bridge cards we were looking at 32 processing paths, with the ability to bridge 32 Full HD or 8 UHD channels, a convert card typically has 16 processing paths, with the ability to fully process 16 Full HD or 4 UHD channels. We're always expanding our portfolio of software versions, so the 16 processing paths are not set in stone. There's a convert version available with 24 processing paths, for instance, but without the SDI I/O capabilities, since again, it's always a trade-off. Neuron convert cards appear in Cerebrum as CPG, CPI or CPS, followed by 4 digits, where the CPG stands for Convert Processing Gateway, CPI stands for Convert Processing IP Only, and CPS stands for Convert Processing SDI Only. The 4 numbers behind the 3 letters indicate the amount of outputs and inputs again, just as with the bridge cards. Likewise, behind the 4 numbers, there's a dash, followed by digits indicating the interface configuration. Some convert cards have an additional dash behind the interface configuration, followed by an L or an H. This letter indicates whether it can do HDR conversion based on BCOM adaptive conversion methods, indicated with an H, or if it uses lookup tables or LUTs to convert from or to HDR, indicated with an L. Let's look at what a convert card can do per processing path, by zooming in on a set of 4 paths. Remember, when looking at the generic structure of a processing board, the paths are ordered in sets of 4. So paths A1, A2, A3, A4, then paths B1, B2, B3, B4, etc. It's designed that way because when working with UHD, you require 4 Full HD channels to process the ultra high definition content. This is especially important for the convert variants, which can do up-down cross-conversion to and from UHD and perform UHD remapping, also known as gearboxing. More about that later. We start with the input stage. Here you can define whether the inputs should be treated as 4 individual HD inputs, or as 4 HD inputs combined to 1 UHD input using square division or 2 sample interleave modes, or if there's a UHD signal coming in over a single wire, so via one of the 12 gig SDI inputs or a single IP stream. Then you can see the input selection. You can assign any of your inputs, IP or SDI, to be the main or the backup input of each individual path. If the input stage is set to single stream, only the input settings of path 1 are used, and the main and backup settings of paths 2, 3 and 4 are ignored. This backup works by input detection and CRC checks. So if there's no valid video detected on the input you configured as your main, the path will automatically switch to the input you configured as a backup input. Setting up the way these backup switches function can be done globally, so for all paths the same rules, or per individual path. Behind the input selection there are the de-embedders, with tracking delay to synchronize the video further down the processing path, and the auxiliary data decoders. These do not have any real settings. These audio de-embedders and VANC data decoders are always on. The next processing block is the most distinctive one for a convert card, the up-down cross conversion. Depending on what you configure as the output format in the output stage, this converter will either down-convert UHD to HD or SD, up-convert SD or HD to HD or UHD, or cross-convert, for instance, 720p to 1080p. If you've watched the Synapse shorts, you'd recognize this diagram, which visualizes the definition of what we consider to be up-conversion, down-conversion and cross-conversion. Standards of frame rate conversion, so converting from 50 Hz to 60 Hz, is currently not yet possible with Neuron Convert. That's why when the frame rate of the input stage is not in the same frequency standard as the output stage, these alarm icons will appear and the output will be invalid. This up-down cross-conversion block is also responsible for remapping or gearboxing your UHD video. You can combine, for instance, 4 HD square division inputs to one single-wire UHD 2SI output. Or take a single stream UHD input and split it into a 4-wire 2SI UHD output. Please note that if you configure the input stage or the output stage as UHD, the 4 paths will be combined. So if you set your output mode to UHD and the input mode is HD, only the input of path 1 is upconverted to a UHD output, and paths 2, 3 and 4 are ignored. Next we have 4 individual frame syncs, or 1 frame sync if your output is single stream UHD, with adjustable offset delay of up to 60 full HD frames. Depending on which version of Convert you have installed, you will find the HDR processing block behind the frame syncs. This can be an adaptive HDR converter, in which case there aren't many settings besides changing the in and the out color space, or a LUT-based HDR converter. If it's a LUT-based converter, you'll see an extra tab in the Cerebrum interface, in which you can manage your 1D and 3D LUT presets. If you want to know more about the various HDR conversion methods and their pros and cons, you should check out our easy-to-follow short animations on evs.com/hdr. Behind the HDR conversion block, there are the individual color correctors. The color corrector can do RGB or YCBCR adjustments, as well as clip and hue adjustments. The last blocks before the output stage of these processing paths are the audio embedding and audio processing blocks, where you can shuffle your audio and change gain and phase settings for each individual embedded audio channel. Please bear in mind that if your output is ST2110, like explained in the previous Neuron short, the video is streamed separate from the audio, and so the audio embedders and audio processing blocks in these video paths here will not have any real effect on the output, unless this path is assigned to an ST2022 or SDI output as well, which is still possible of course, because you can still assign any of these processing paths to any of your IP or SDI outputs, even to multiple outputs at the same time. As you've seen during this explanation, the Video Paths tab in Neuron's graphical user interface in Cerebrum always visualizes the conversion each path is currently processing. So if you change the input format to HD and the output format to 4-wire UHD, you can see path A1 only going in, being converted into 4 times HD combined to UHD. When your input is UHD single wire and the output is HD, you'll see path A1 represented by a thicker UHD arrow being converted into 4 times HD, where all 4 paths contain the same down-converted video, but each with individual frame sync, color corrector, embedding and audio processing settings. The IP Video I/O and IP Audio I/O tabs are similar to what I've shown you in the previous Neuron short, only with less input and output streams. And similar to the bridge cards, each video, audio or data input and output stream has 2 legs. These can either work in a -7 redundancy standard, so switching per packet, or in a dual leg -7 redundancy method, only switching when a stream is not available anymore. Also, the separate ST2110-30 audio streams and the way the audio matrix works are similar to what I've shown you in the video about the bridge cards, where on the audio paths tab you can see which audio input has which channel number, and on the IP Audio I/O tab and in the embedder settings of each video path you can configure which audio channel goes where. And that's the convert range. Of course, we'll keep adding functionality to the convert cards, like auxiliary data processing, Dolby encoding and decoding and MADI I/O, which I didn't show you in this video. See you in the next Neuron short, which will be about the protect range.